Hello, welcome back. And for this week, we will cover up one example of Honeywell Industrial Control, and this one is 7795. And hopefully, if you get the gist of one control and how does it operate, you will know that the other ones are not going to be that much difference. And I will post a few PowerPoints about the other controls along with their manuals. Okay, so far we've covered the flame rods and optical detectors, how do they function, how do they vary, and the requirement. We talked about valves and valve trains for gas boilers and also oil boilers, sequence of operation, the 5 steps or 6 steps of operation, and the major components being the pilot line and the main fuel. Now I would like to talk about firing rate controls. How do we control the firing rate from low to high in our industrial boiler? What's the firing rate. Basically, we control the amount of gas and whatever air that goes with the gas depending on the temperature and the firing requirement. And firing rate is the combustion rate, how much fire are we making inside the chamber. It is the rate at which the air and fuel mixture is supplied to the burner motor or furnace. So the firing rate is how much fuel and air we're putting inside the chamber and hoping that it will completely combust completely and produce enough flame and heat. It's usually expressed in volume per foot cube, so it's volumetric. Weights, you can see it in weight, and that will dictate that we have the pressure. Sometimes it's given by BTU per hour, so they vary from one industry to another, but firing rate can be expressed in either one of those. Uh, the purpose is to simplify the operation, to have less uh, staff monitoring the boiler. We can reduce the workload, and now we can have a plant operating with minimum of 1 or 2 operators around the clock. It's better economy. Again, uh, it's better to control the fuel and air coming into the boiler than to try to control um, the things manually. It's good to know how much steam pressure we're producing than to just try to add and mix as we go along. Also, so it's good to have the right amount of steam pressure. The system can control also the air and fuel ratio. It can control the draft, how much draft do we have inside the chimney and inside the chamber. Also, the system will be able to control the water level in the system and also add up some makeup water. And also monitor the water quality to tell you that maybe it's time for now to do a purge or a system blowdown. And we can also control, as we control the steam pressure, we can control the steam temperature. We know they go both together. Case In this case, we have parallel control where we control the steam pressure is our output point. We send the signal to the fuel pump, and we modulate the air coming in based on the fuel pump using a cam. I will show you how. So we have continuous firing all the time, or we can have on or off. So if you look at the clothes dryer, it's always on, as the heat giving off by the clothes dryer usually is constant the whole time. Or we can have on and off to control temperature as needed. Or we can have a high and low firing rate, so we can have a boiler that puts in high and low setting, and we can modulate between those two, so it doesn't have to be off completely, but just a little bit lower. Or we can have an MDM where we can have the same nozzle and the same flow rate. It just goes from big flame to small flame. That's an MDM. It's called modulating motor. Usually it's provided and controlled by linkages between the firing pump and the rate given by the control. It works inside. It has a cam connected to a mechanical linkage that links the fuel valve and the air damper to allow as much air to come in. And again, it has a rotating mechanical linkage, so it's completely mechanical with a small motor inside to open that damper. So this is what it looks from the inside. There's a small transformer, and this is the terminal board that controls the high fire cam and the low fire cam, and again it's connected by 2 connection in here with the linkages. So what's a cam? It's how a cam work. A cam basically is a timing gear. It's misshapen gear, as you can see, so it can open or close this valve based on the size of the diameter of that gear at that moment. So if probably you have that in your car, and probably you heard about twin cams and camshaft and etc. This is a camshaft, and the camshaft have those little oval shaped gears to open and close valves as needed. So one of them will allow the fuel in, and at the same time the other will allow the exhaust to come out. So you have two valves in the same chamber. So the most common problem we can have in controls, like the one we're going to talk about, is faulty connection between the wires. It happens more than you think. You have loose connection or a charred or nipped wire where the insulation is exposed and it's kind of shorting somewhere. So we want to check for loose connections. Dust, or it can be corrosion from moisture. There could be a leak in the plant or a steam leak somewhere, and that steam or rust that steam or water can cause corrosion in some of the wire or connections between them. So again, we want to check the connections and the wires, and even the sleeved one that should be checked, because sometimes they're really hard to get to, but you can have some corrosion inside those little connections. Failure of resistors board, that's also possible. Resistance harness or slippage of the cam. So the cam inside the MDM that we saw can slip a little bit. It has to be readjusted. So usually they get sent out and they get readjusted. Failure of transformer inside the MDM, that could be another problem. And I will move on to the class 2 after I post this video.